a function, any function, let's say natural log x plus 2x squared, and let's say we have between 2 and 10, so the average rate of change is simply f of 10 minus f of 2 divided by 10 minus 2, which is 8. So the average rate of change between 2 and 10 has nothing to do with calculus. Now, if you want to talk about the average value of the function on 2 comma 10, that is different. Is 1 over 10 minus 2 the integral from 2 to 10 from f of x dx. So if you remember a long time ago, I said there are so many different concepts with the average and rate of change and this and that, and average value, blah, blah, blah. They are confusing. So the average rate is basically algebra. It's nothing else but the slope of the line passing through 2 comma f of 2 and 10 comma f of 10. This one is the average value of a function on an interval, and that has a different definition. It's what we learned in chapter 4.
Okay, I was literally reading word for word one of the sample practice problems in test 1.
Okay, so in test 1 it could have not been this because we did not get to integration then. So if it's just the average rate or the average rate of change, because if it's the average rate, is this. If it's the average rate of change, or basically it should not be, so just the rate of change, the rate of change, then it's f prime of x, which for this function will be 1 over x plus 4x. So we have the average rate, which is algebra. We have the average value of a function, which is chapter 4. And we have the rate of change. So let me remove all those from there. So the rate of change is just simply f prime. So which one are we looking at?
The problem says f of x equals square root of 2x minus 1. Find the average rate of change of the function between points.
Okay, it's
x
this.
Equals 1 and x equals 5.
Yeah, it's this.
Okay.
Yeah, it's just algebra. I shouldn't say just algebra. It's just algebra. We plug in the values, and it's f of 10 minus f of 2 over 10 minus 2, which is 8. Good, very good. Next question. Okay, let's go back. Is there anything else from here that we want to look at? Or we can go back to test 1 and see what we have to review from there. I have to wait for this. So I think that this is what happens when Zoom is on and Canvas is on, and okay. Review for test 1. I would redo, if I were you, between now and the final exam next Tuesday, I would review every review, not just from our class, from the previous 3, 4, 5 classes. So this is what I was saying. The average rate of change requires 2 points. The rate of change is just the derivative. The value of the rate of change is we have to evaluate f prime at a point. The instantaneous rate of change is basically the same idea. The average profit, cost, or revenue is something else. The rate of change of the average profit, cost, and revenue is the derivative of these functions. And now we're adding here the last one, which is the average value of a function, which is the formula that I just put up. So here we have the product rule, the quotient rule, the chain rule. Graphing a piecewise defined function, that is a mandatory topic. And finding the continuity or differentiability. Compound interest, domain, equilibrium point, which we use anyway for consumer surplus and producer surplus, limits, continuity, differentiability, definition of continuity at the point, use a definition of the derivative to find f prime, differentiation rules, average profit, cost, revenue, and derivatives for those, distance, velocity, acceleration, higher order derivatives, and equation of the tangent line. So what do we want to refresh our memory on right now?
The equation of the tangent line.
The equation of the tangent line, very good. So the equation of the tangent line is one of what I think is the easiest of all. So you're given a function, like for example this one, natural log x plus 2x squared. Of course you have to find f prime, which is 1 over x plus 4x. And if we're given a point, when x is 1, y is 2, how do I know this? When I plugged in 1 here, this is 0. When I plug in 1 here, this is 2. So in order to find the equation of the tangent line, you have to write y minus y1 equals the slope times x minus x1, where your x1 is 1 and y1 is 2. But you have to determine this. But this is very simple because you already have f prime. All you have to do is just plug in 1. 1 over 1 is 1. 1 plus 4 is 5. So this is it. So when you're asked to find the equation of the tangent line to the graph of a function at a particular point, you have to write the equation, the point slope form. You have to find the derivative and plug in 1, and that will be your slope. So f prime of 1 is always the slope. And now you have, and that's my page 8. So now you have y minus 2 equals 5x minus 1. So this is 5x minus 5 but plus 2. So this is your equation, the equation of the tangent line to the graph of the given function at the point 1, 2. I hope that this question is going to become the easiest possible for you. That's all you need to do. Just remember that the slope of the tangent line is nothing else but f prime at that point. Thank you. So now let's go back and see what else we want to look at. From test 1. What about graphing a piecewise defined function? I know we had 10 examples, but still, not everyone is comfortable with it.
Can we do one of those?
Sure. I'm going to make one up. If you have one, I'll wait for yours. If not, I'll make one up. Okay, then. So let's say I have 1 over x for x greater than or equal to 1. And let's say I have e to the x for x less than 1. So this is a piecewise defined function. I will immediately find f prime of x, because I know that this is negative 1 over x squared for x greater than or equal to 1. And I know that e to the x prime is e to the x for x less than 1, because the problem will ask me the derivative as well. Now, is this function continuous? I don't know. So I should not put closed just yet. I'm going to put a question mark and I'm going to come back. So remember continuity. The problem is going to ask you about the definition of continuity at a point. So you have to write that the limit as x approaches a from the left of f of x must equal the limit of f of x as x approaches a from the right must equal f of a. This has to be on your paper. If a problem is asking, state the definition of continuity at the point. The point is when x is a. You have to write this. Now, the limit from the left. So this is the limit as x approaches 1 from the left from e to the x. Then the limit as x approaches 1 from the right of 1 over x. And then f of 1. F of 1 is 1. But this cannot equal this, which is equal to, these two are equal, they're 1. But e to the x, this limit, is e. E cannot equal the limit of 1 over x and cannot equal 1. So not continuous at x equals 1. Okay, now I discovered all this information. Now I'm ready to graph. Here's my table. Here's f of x, negative infinity to infinity. I have to have 0 in the table and I have to have 1 in the table. Why 1? Because this is a key element here. So to the right, it's a bracket. To the left is a parenthesis. To the right, I will be using 1 over x, and to the left, I will be using e to the x. Good. So now I will plug in numbers. When I plug in 1, I get 1. When I plug in 2, I get 1/2. When I plug in 1, I get e. When I plug in 0, I get 1. That's all I need. So at 0, let me use a different color. At 0 is 1. At 1, this is 2.7, so somewhere here. I know the graph of e to the x. So that's why I used red for the left, let's say, a different color, and now I'm using whatever this is. So at 1 is 1. At 2 is 1/2. And that's the graph of 1 over x. How do I know these graphs? Well, e to the x looks like this. And 1 over x looks like this. But I cannot graph this piece because 1 over x is only from 1 to infinity. Only from 1 to infinity. So it has a jump. The function is not continuous at that point. So therefore, it cannot be differentiable. And I will say correct. Not differentiable because it's not continuous. So that's why I can only have the open here and open here. No equal symbol. Not differentiable at x equals 1 since it is not continuous. If it's not continuous, it cannot have a derivative there. And that's the all analysis that I need. Continuity at point, and I showed why it's not continuous. The derivative, but I don't close. I would have closed it if it were continuous and no corners or cusps. Then the table for the graph, and I make sure that I put everything on the table because otherwise I may get confused. I may plug in the wrong function. Who knows? And my graph is not perfect. I just realized it's not exactly vertical here. So this should be right on top, on the same vertical. Oops, everything, see? So it's not perfect. My graph is not perfect, so I have to adjust it a little bit. So this is open, and I'm going to move the bottom one a little bit to the right. So this has to be open. Okay? So on the same vertical. And then it goes to the right. So remember, these have to be one on top of the other. Because this is what happens at 1. The limit from the left is e, the limit from the right is 1. Very good. Any questions on this problem? So it has a jump, not continuous, but and of course not differentiable at that point. Good. Anything else?